The fatal flaw inside AI models nobody saw coming. AI's hidden flaw. The catastrophic overtraining crisis. Artificial intelligence has reached astonishing heights. From writing code to diagnosing illness, AI models are becoming smarter, faster, and seemingly limitless. But what if all this growth has a hidden flaw? One so critical it could break the future of every major AI system. Not a security breach, not misinformation, not hallucinations. Something deeper, more structural. This isn't just speculation. Researchers from some of the world's top institutions, Stanford, Princeton, Harvard, Carnegie Mellon, have uncovered a flaw they call catastrophic overtraining, and their discovery has sent shockwaves through the AI community. Let's break it down and see why this could change how every AI model is built from now on. 1. The assumption that shaping AI has always followed one core philosophy. The more data you feed, the better it performs. Larger data sets, more compute, longer training hours. That's how we got from GPT-2 to GPT-4, from niche tools to enterprise-grade assistants. But the new research challenges this idea head-on. It turns out that after a certain point, more data doesn't just stop helping, it actively harms. Models become more rigid, harder to fine-tune, and less capable of adapting to new tasks. And this isn't just a theoretical concern. It's already been observed in action. 2. The study that shook the field. In March 2025, a paper titled Overtrained Language Models Are Harder to Fine-Tune was published on AR-Quaranchev. The lead author, Jacob Mitchell Springer, alongside top AI researchers, introduced the world to catastrophic overtraining, a point where continued learning actually begins to degrade performance. Their test case? A model called OM1B, created by the Allen Institute. 2 versions were trained, one on 2.3 trillion tokens, another on 3 trillion tokens, a modest 30% increase. Logic says the larger one should be smarter, but the opposite happened. After instruction tuning, the bigger model performed worse across multiple benchmarks, not slightly, consistently, repeatedly. The 3 trillion token version became harder to adapt and even lost capabilities it previously mastered. 3. Why overtraining breaks AI? To understand why this happens, the researchers explored a phenomenon they named progressive sensitivity. Think of a model's parameters, those millions of numbers, as flexible wires. Early in training, these wires adjust freely, forming patterns and relationships with language data. But the longer training continues, tighter and more brittle those wires become. By the time training crosses a threshold, around 2.5 trillion tokens in this study, those internal systems grow so locked into specific patterns that even minor changes, like updating a skill or adapting to a new format, can shatter previous progress. This isn't a bug in the code, it's a fundamental byproduct of how models are currently built, and this rigidity causes something unexpected. Forgetting. A model trained too long starts losing old strengths while struggling to adopt new ones. 4th, real-world consequences for developers. For AI engineers and developers, the consequences are staggering. Big tech has poured billions into ever larger models. GPT-4, Claude 3, Gemini, LLaMA3, all based on the assumption that more is better. But what if they've already crossed the danger zone? Many of these models are rumored to be trained on 10 trillion tokens or more, but companies like OpenAI and Google never reveal their exact data volumes or thresholds. That opacity is part of the problem. If catastrophic overtraining applies to all models, as the study suggests, then some of the largest systems in the world may be overtrained and losing adaptability with each update. It could explain why some fine-tuned versions of ChatGPT behave inconsistently, or why models become great at instruction following but start losing creativity. 5. Why it matters for everyone, not just coders. You don't need to be a machine learning expert to feel the impact of this flaw. Startups using open source models like Mistral or Llama for healthcare, education, or finance are already customizing them through fine-tuning. But if those models have crossed the overtraining threshold, fine-tuning becomes a liability, not an upgrade. Artificial intelligence in legal firms, AI in hospitals, AI in classrooms. These aren't just test environments, they're real-world systems where adaptability, reliability, and trust are everything. A brittle model isn't just inefficient, it's dangerous. 6. Can catastrophic overtraining be fixed? Here's the hard part. There's no silver bullet. The research team tested a range of mitigation strategies, lower learning rates, regularization techniques, careful instruction data. All of them helped delay degradation, but none stopped it entirely. Even models trained with precision still underperformed once they crossed the 2.5 trillion token line. This reveals a chilling trade-off. Train longer, and your base model gets stronger, but it becomes increasingly harder to tune or adapt. That's a problem for models meant to evolve, handle changing tasks, or work across multimodal inputs like images, audio, and text. 7. Are we already past the point of no return? The deeper question is whether some AI giants have already gone too far. Look closely, and you'll find symptoms aligning with overtraining. ChatGPT versions that gain logic but lose memory. Claude models praised for alignment but struggling in real-world apps. Gemini excelling in context tasks, yet showing erratic reasoning in image-text combos. These aren't bugs, they could be signs of progressive model decay. And the kicker, you can't just patch this flaw because it's not in the post-training pipeline. It's baked into the pre-training phase, the very foundation of a model. No amount of data, plugins, or interface changes can undo it. 8. What the future of AI needs to look like. This flaw is not the end of AI, but it forces a shift in how we build and evaluate models. Until now, scale was everything. Bigger meant better. But now developers will need to prioritize stability and adaptability. We're entering an age where pre-training thresholds must be defined and respected. Fine-tuning becomes a balancing act, not just a final polish. Structural limitations must be part of model architecture planning from the beginning. Institutes like ETH Zurich and Berkeley are already exploring whether newer systems, like mixture of experts and retrieval augmented generation, face similar overtraining vulnerabilities. But one fact remains: training alone can't guarantee success. 9. What this means for innovation, safety, and trust. If catastrophic overtraining becomes a widespread issue, AI innovation could hit a ceiling, a dangerous one. Imagine rolling out a billion-dollar model across hospitals only to discover its performance degrades with every new update, or releasing an educational tutor AI that suddenly forgets how to simplify concepts after learning new ones. Trust in AI doesn't just depend on accuracy, it depends on reliability across time and change. And that means understanding overtraining isn't just a research problem, it's a product design problem, a user experience problem, a deployment risk. 10. A new frontier, balancing power with flexibility. So where do we go from here? We need metrics that go beyond benchmarks. It's no longer enough to say a model scores high on tests. We need to ask, can it adapt? Can it retain old skills while learning new ones? Can it evolve without decay? New training frameworks might involve adaptive pre-training objectives, earlier integration of tuning tasks, more transparent disclosures about token volumes and inflection points. The industry can't afford to treat overtraining as an afterthought, because in a world where AI runs critical systems, from emergency response to autonomous navigation, rigidity is a threat. Let the race slow down before it breaks. AI has dazzled the world with its power, but in chasing limitless growth, we may be ignoring the warning signs flashing under the surface. Catastrophic overtraining isn't a failure of AI, it's a flaw in our approach. And fixing it won't come from building faster chips or feeding more data. It'll come from understanding the fragility we've created. If you found this topic eye-opening, share your thoughts in the comments. Is AI growing too fast for its own good? And should companies be more transparent about their training processes? For more in-depth analysis and critical tech discussions, make sure to like, comment, and subscribe to stay updated. The next era of AI won't be about scale, it'll be about balance.